everyone, I am Lorna Williams, a trained mathematics teacher. Welcome back to my channel, Bloom Your Math and A is Your Grade. This is a class where I teach you mathematical concepts and then provide you with worked past paper questions in our Take 5 series. Today's topics are singular and inverse matrices. So, let's get started. Here's question 4. Let's read it together. Given the matrix R equals 2, 1, negative 1, 3, show that R, that's a matrix R, is non-singular. Now, just a reminder that if a matrix is non-singular, the value of the determinant can be any number except 0. Come again. If a matrix is non-singular, so what's the opposite of singular in matrix? Non-singular, not plural. Remember that math has its own jargon. Now, what is a singular matrix? The value of the determinant is equal to 0. That is when it is singular. When it is non-singular, then the value of the determinant is not equal to 0. So it can be any number except 0, any real number. So we're talking about it can be a fraction, it can be a decimal, it can be a negative number, it can be a positive number, but it must not be 0. So they ask you to show. So our aim is to prove. Okay. So it says the value of the determinant. So how do we find the value of the determinant? What's the formula? It's AD minus BC. And the value of the determinant can be any number except 0. So it must not be equal to 0. Is that clear, everybody? Okay, great. So first we need to know now what is A, what value is A, what value is D, what value is B, and what value is C. So we go up to the matrix that was given and we're going to be labeling them. Don't forget now that the top left is always A. The bottom right is always D. Then the top right is B, bottom left is C. And once you can label that, you are good to go. Because you're just going to substitute it now into the formula. Substitute all those values. So remember that 2 letters beside itself really means that we are multiplying. So if I see 2x, it means 2 times x. If I see mn, it means m multiplied by n. If I see ad, it means a multiplied by d. So I'm going to be multiplying a, the value of a, which is 2, and I'm going to use a bracket here to show that I'm multiplying these two numbers. Alright, so that's 2, and d is 3. Then what comes after is a minus sign. And then another open bracket, b has a value negative 1, and c has a value 1. And I always like to put equal sign on the equal sign, or not equal sign on the not equal sign on the sign, just for alignment. Okay? Not equal to 0. So we're trying to work the left hand side now to prove that it's not 0, because we know that if it's 0, then 0 is equal to 0. But if it's any other number, then we know then that number is not equal to 0. So we're trying to work the left hand side. Okay? So 2 times 3 is 6. Yes. Negative 1 times 1 is negative 1. And we're going to simplify this. These two signs combine to give me a plus, and 6 plus 1 is not equal to 0. 7 is not equal to 0. And you can make a nice little note by saying that since the value of the determinant is 7, is 7, then matrix R is non-singular. You got that? Give yourself a clap if you got it. Alright, let's now move on to part 2 of question 4. It says find R to the minus 1, which is the same as the abbreviation for the inverse of R. And the formula is 1 over the determinant times the adjoint of R. Alright, so now it's R to the minus 1 is equal to 1. Now we already, if you look over here, you would have realized that the formula for the determinant is AB minus BC, and we worked it out to be equal to 7. So we don't need to work this out again over here. Okay? So I'm just going to put 7 there. And then there are 2 steps to find the adjoint. 2 steps. Step 1 is to interchange these 2 numbers, 2 and 3. They're called they're in the main diagonal. Just like how you have a square or a rectangle, from one corner to the opposite corner is a diagonal, and you have your 2 here and your 3 here. You're just going to interchange these numbers. So this is 3 and this is 2. And then, I like to always circle the main diagonal so I don't get mixed up. I don't have to circle the other 2. Because all I'm going to do now is to multiply each of these numbers by negative 1. Or you can just simply say, I'm going to change the sign. So it was a negative 1, it now becomes a positive 1. This C has a value 1, it now becomes a negative 1. And basically that's it, for part 2. But we can go a step further, because suppose if you want to give your answer as a fraction, then this 1/7 is called a scalar number. And all that it's going to do is to multiply, you're going to multiply each of these elements in the brackets by 1/7. Kind of remind of the distributive law, don't it? Right, so we're going to multiply 1/7. So this 1/7, I'm going to multiply it by the 3 first. 1/7 times the 1, 1/7 times the negative 1, and 1/7 times the 2. Do you remember how to multiply fractions? Well, if you don't, I can quickly remind you, all you do is put each of these numbers over 1. Since nothing can be cancelled, you multiply numerator by numerator and denominator by denominator. If those words sound big to you, you multiply the 2 top numbers and the 2 bottom numbers together. So the 2 top numbers, 1 times 3 gives me 3. Over 7 times 1 is 7. 1 times 1 is 1. 7 times 1 is 7. 1 times negative 1 is negative 1. 7 times 1 is 7. 1 times 2 is 2. And 7 times 1 is 7. Again, it's okay to leave your answer like this without the multiplication sign for simplicity. Or you can go a step further and leave your answer as a fraction. In either way, you will get full marks. The part 3 says, show that R, that's the matrix R. Now, these just look fictitious to you, you know. But this R is really what we name the matrix over here, R. So instead of writing out all of this, I just call it R. You get me? So this is the original matrix, which was the matrix that was given. So we call it R. And then, does this ring a bell? R to the minus 1? Yeah, because today we just did it. I is the one that you may not have remembered, and I quickly scribbled it here. I is called the identity matrix, and again, I have really looked at it um, in previous videos, and you can always go back to those videos. So we have our times. Now you notice I put a multiplication sign here because two letters beside each other means that we are multiplying them. Just like AD means A multiplied by D, R times R to the minus 1 means R multiplying, but they take out the multiplication sign just for simplicity. Okay, they're simplifying it, but it really means that we're multiplying the original matrix by the inverse. So these two will be beside each other. You don't think so? Yeah. And then when we multiply them, what answer should we get? This. And if you don't get that, guess what? Your answer wrong. So check again. You may have made a slight mistake. So if you give them 5, -6, they will realize that you haven't a clue what you're doing. So we don't want them to think that, don't we? Alright, let's go. So R is 2, 1, -1, 3. That's original matrix. And in part 2, we found the inverse to be 3, 7, 3 over 7. Let me make this bracket a little bigger. -1 over 7, 1 over 7, and 2 over 7. Again, it says show. So you don't even have to write equals 1, 0, because we want, once we work this out and we get that answer, we just put beside it in brackets, proven, and we're good to go. Now, I hope you remember how to multiply 2 by 2 matrices. You see, there are a lot of concepts for you to remember, so check again my videos. But I'm here to remind you. So, when you're multiplying 2 by 2 matrices, and why is this 2 by 2? We have 2 rows. We have 2 rows. Rows go across. So there's 2 and -1, 1 and 3. Those are 2 rows. Okay? And we have 2 columns. Not another column. 1, 2. You get that? So that's why it's called a 2 by 2 matrix. So for multiplication of matrices, the idea is to multiply the rows in the first matrix by the columns in the second matrix, like RC, Roman Catholic. It's not Catholic Roman, no, it's Roman Catholic. So the order matters. So we're going to have row 1. Remember, it's just the rows we're focusing on, right? Row 1 and row 2. So these rows we're focusing on in the first matrix only, nothing else. And in the second matrix, we're focusing on the columns. Column 1, column 2. And to really get so that you don't get lost, our answer is always going to be a 2 by 2 matrix. Okay? So I'm going to make life easier for you. That's 2 rows and 2 columns. So for the first element, we are going to multiply row 1 by column 1 and add the results. We are going to multiply row 1 by column 2 and add the results. All these I've taught already, but Just take a time, relax, take a deep breath, right? And see if you can recall what you have learned. And I'm slowing down a little bit just for you, okay? So it's values I'm going to put on top here, calculations I'm going to put on top here, But in order to get this answer, I have to multiply row 1 by column 1. In order to get this answer, I have to multiply row 1 by column 2 and add the result. This one is row 2, column 1, and row 2, column 2. So you notice the top is all about row 1 and the bottom is all about row 2. Alright? So let's set it up now. And I'm setting it up much bigger so you can see all the calculations we're going to be doing. Row 1. We're going to multiply the first element in the row by the first element in the column. Get that? 2 times 3, 7. Then we're going to multiply the second element in row 1 by the second element in column 1. So I'm going to make life easier by saying now, first with first, second with second. And that should hold us for get ahead of it quicker. So second with second, negative 1 times negative 1 seventh. And this is row 1, column 1. Now we're on to row 1, column 2. So row 1 has the number, remember row goes horizontally. So 2 times 1 7, first with first, second with second. Now we finish off with row 1 now. We're on to the bottom one, row 2. What are the elements in row 2? 1 and 3. So that's row 2, column 1, row 2, column 2. Let's go. Row 2 has two numbers, 1 and 3. First with first. So we're heading for column 1. 1 times 3 7. Plus second with second. 3 times negative 1 7. And as we go along, we simplify. Row 2, again, this time now with column 2. What are the elements in column 2? Two fractions, 1 7 and 2 7. This is the first column, first element in the column, and this is the second element. So 1 with 1 7 added to 3 with 2 sevens. And I'm putting an equal sign there because now we're heading to simplifying it further. Again, this is a whole number 2, but I can write it as a fraction so I can do the multiplication. 2 is the same as 2 over 1. In this case, now we're multiplying the two top numbers. 2 times all the two numerators. 2 times 3 is 6. And let me draw back those 4 lines. 2 times 3 is 6. 7 times 1 is 7. Plus negative times negative is a positive 1. Negative times negative is positive 1 over 7. Row 1, column 2 now. Let's put 2 over 1 so we can multiply the two top numbers. 2 times 1 is 2 over 2 times 1 is 2 and 1 times 7 is 7. Plus, Let's put the negative 1 over 1. In other words, I'm turning all whole numbers into fractions so we can multiply across. So negative 1 times 2 is negative 2, and 1 times 7 is 7. Down here, we have 1, but I'm turning it as 1 over 1. So 1 times 3 is 3, and 1 times 7 is 7. Plus 3 times negative 1, and let's put 3 over 1. You don't have to do that, but for those who can't see clearly, I'm willing to go the extra mile. So 3 times negative 1 is negative 3, and 1 times 7 is 7. And the last one, let's put 1 over 1. And while we're at it, let's put 3 over 1. 1 times 1 is 1 over 7, plus 3 times 2 is 6 over 7. Woo! Wasn't that a lot of work? I feel it. You felt that? I felt it too. Okay, so we are now gonna end up now writing the answers, and if we don't get 1001, which is identity, and the identity behaves like 1 in ordinary multiplication, but we'll get to that some other time. Our aim is to show that when we multiply r times its inverse, it gives me the identity. Okay, so 6 and 1 is what? Since the denominators are the same, then we can just add the numerator. We don't need to find the LCM because we already have a common denominator. So 6 and 1 is 7. And 7 over 7 is the same as what? 1. 7 divided by 7 is 1. So I can say, I'm moving out those lines now. We will graduate from that, right? So we're going to put 1 there. Let's go down the line. 3 sevens plus negative 3 7. What is 3 plus a negative 3? You have 3 and it's your whole directed numbers come into play. You have 3 and you owe 3. You don't have nothing to do. So that's 0 over 7. And 0 divided by any number is 0. Are we going on good so far? You must always peep up, to see if you're getting it, on the right track, We have now 2 plus negative 2. You have 2, you owe 2, that's 0 over 7. And 0 divided by any number is 0. 1 plus 6 is 7. And 7 divided by 7 is the same as 1. So, that's proven. So you'd have said, therefore, r times r to the minus 1 is equal to the identity. And this 1001 has a special letter, it's called I. No other letter but I. So if you write it as M, you're wrong. It is called I. One little thing I wanted to explain to you is that it's not every matrix has an inverse. Not every matrix has an inverse. Because notice that the determinant for this question was 7. You follow? And so we had 1 over 7. But what if we got the determinant to be 0? And you have in your formula here 1 over 0. What is 1 divided by 0? Check your calculator right now and tell me the answer. Are you listening? 1 divided by 0. You get the error message? Yes. So 1 divided by 0 is meaningless. And we have worked question 4. I hope you enjoyed it. And look here, it's not just r, because you see r times r to the minus, it can be any letter. Tell me now, what is a times the inverse of a? I. What is m times the inverse of m? I. What is L times, so in other words, in summary, the original matrix times its inverse is always going to give me the identity matrix, which is a square matrix of 1, 0, 0, 1.
That's it from Bloom Your Math. Affirm today, I can achieve excellence in mathematics. Don't forget to like, share, and subscribe. You may hit that notification bell to alert you when I get new videos. Bloom Your Math, signing off. Bye.